Hello, our topic for today is we are beginning normal distributions. So the essential question, we need to lay the groundwork first. What is a normal distribution? And how are normal curves used to help draw conclusions about data? So you may have heard of a normal distribution before, just maybe not in those terms. You have your formal definition here, a continuous probability distribution that is symmetric about the mean. It is often referred to as a bell curve. And that last thing in parentheses is where you may have heard that before, bell curve, because a normal distribution is shaped like a bell. So that brings us to our very first property listed below. A normal distribution is shaped like a bell. It is symmetrical about a vertical line through I'm going to draw the character. It's called mu. And it kind of looks like an M. It kind of looks like a U with a really long line in front of it. The curve approaches the horizontal axis, but it never touches or crosses. Never touches or crosses it. We have what are called transition points between cupping upward and cupping downward. If it's cupping upward, then it'll be between what's called mu plus sigma and mu minus sigma. I will go back, I'll scroll back up in case you need to pause and write any of this down. Mean is something we've talked about before. You are calculating the sum of the data points and dividing by the number of points that there are. So again, that's called the mean, but what we talk about it in terms of the standard or the normal curve is called mu. So anytime you see that mu symbol, you're talking about the mean. And then a standard deviation is a way to normalize the data set because you could be talking about someone's height. You could then go to talking about someone's weight. This is a way to normalize just a bunch of data sets, even if they have different units of measurement. So we call a standard deviation sigma, and it looks like a circle with a tail coming out of it. So for the graph of a normal curve, they again are symmetric about the mean, and they have key data points that are highlighted within certain standard deviations. So we talked about on the last page, there's a transition point between cupping upward and cupping downward. Anytime it's cupping upward, that interval will contain 68.2% of the data. Anytime it is cupping downward, you have the remaining 31.8%. If you are looking within one standard deviation, and that's again positive or negative, so you could be one above or one below the mean, that's going to contain 68.2% of the data points. If you are within two standard deviations of the mean, so you can be two below the mean or two above the mean, that's going to contain 95.4% of the data. And then approximately 99.7% of the data will fall within three standard deviations of the mean. So the way this looks, here's our mean, we call it mu. And you can tell that this is a standard normal curve by looking at its shape. So if I were to draw a line up through the peak, that dotted line that I just drew is called mu. It is symmetric on either side of the line. And I can measure out very clearly where the standard deviations are, how far away one standard deviation is, and two, and so forth. So this point right here would be one standard deviation above, or mu plus sigma. And then here, this would be the same thing as mu plus 2 sigma. And then here would be mu plus 3 sigma. And this works below the mean as well. So if you're one standard deviation below the mean, that's the same thing as mu minus sigma. If you are 2 standard deviations below the mean, that's mu minus 2 sigma. And then 3 standard deviations below the mean would be mu minus 3 sigma. So what are the steps to drawing out a normal curve? This example is telling us sketch the graph of a normal curve with a mean of 15 and a standard deviation of 3. So step 1, draw the horizontal axis so that the mean is in the middle. Step 2, create a scale that includes at minimum 3 standard deviations below the mean and 3 standard deviations above the mean. So down below, I'm going to work on those first 2 steps. I'm going to draw my horizontal axis. I'm going to put the mean, or mu, right in the middle. It was given to us that this mu is 15, and then the standard deviation is 3. So we need to make room for 1, 2, 3 standard deviations above the mean, and 1, 2, 3 standard deviations below the mean. So the other part of this, it said, if you were 1 standard deviation above, you have mu plus sigma. One thing that might help you, right away say what mu or your mean is, which is 15 for us, and right away say what sigma is, which is 3. So for that area where I wrote mu plus sigma, you can take your mean of 15 and then add 3 and get 18. And I'll clean that up a little bit for you. And then for 2 standard deviations above the mean, we have to take mu plus 2 sigma. So you take the standard deviation of 3, multiply it by 2, you get 6. Add that on to 15, and you get 21. And then to go 3 standard deviations above the mean, take sigma, which is 3, multiply it by 3 because we're going 3 standard deviations above, and then add that on to 15, 24. So we have 15, 18, 21, 24. To go below the mean, you do the same thing, but this time instead of adding sigma, you are subtracting it. So 15 minus 3 is 12. 15 minus 2 times 3, you get 9. And then 15 minus 3 times 3, you get 6. Okay. So then the next part, step 3. Draw a vertical line at the mean. Just like so. When you draw your bell shape, this is step 4, you want to draw the curve so that it opens down between the mean and 1 standard deviation, just like this. and then complete the curve so that it opens up beyond 1 standard deviation. Like that. It should get close to your horizontal axis, but it should not touch. So for our example, we are assuming the heights of college women are normally distributed, which means they fit the bell curve, with a mean of 65 inches. So before I even keep reading, I'm going to write that down right now. Mu equals 65. Okay? And a standard deviation, oh, that's assigned to, that is our sigma of 2.5 inches. So the first question is asking us, what percentage of women are taller than 65 inches? That is our mean. Okay, and notice how I'm looking up at the example above it, right here. Notice how on the mean, there's the same amount of data to the left as there is to the right. That makes, and every single time we have a normal distribution, that means 50% of the data, or 50% of women, are taller than 65 inches. The second question is saying what percentage of women are between 62.5 inches and 67.5 inches. So first, and for this section, it's okay if we do this, we want to test to see how many standard deviations away from the mean that we are. So we'll try our mean, or mu plus sigma, and mu minus sigma. So for us, that would be 65 plus 2.5, and then 65 minus 2.5. You get 67.5 and 62.5. Perfect. So again, flipping back to our graph of the normal distribution, we're within mu minus sigma and mu plus sigma. So that means that 68.3% of women who play college basketball will be in between 62.5 and 67.5 inches. And then what percentage of women are between 60 inches and 70 inches? Okay, so we already did mu plus sigma and mu minus sigma. Let's try now. What is mu minus 2 sigma? And then mu plus 2 sigma. Mu is still 65. Subtract 2 times our mean, or sorry, 2 times our standard deviation. And then take the mean plus 2 times our standard deviation. You take 2 times 2.5, you get 5. And this becomes 60 and 70. So again, using the graph of that normal distribution, we are within 2 standard deviations of the mean. So that means that 95.5% of the data, or 95.5%, will fall between 60 and 70 inches. Today is just the introduction to this. We will continue to work more with the normal curve because it's a really important statistics topic, and it's something you can expect to see as you take later, not even math courses. This applies to courses that are outside of math. So good luck. Let me know if you have any questions.